Okay, here we're going to be discussing some properties of radicals, specifically this first one that's listed here, with the goal of simplifying radicals. Now, the way this property works is that if we have two numbers multiplied together inside a radical, we can separate it into the square root, in this case the square root, of the first number times the square root of the second number. And if you can actually do one of those radicals, like the square root of 4 is 2, it allows us to break down the radical. So that's what this property is most often used for. You also use it when you multiply radicals. So if you're doing radical 12 times radical 3, you can multiply the insides together applying this property, giving you radical 36, and then the square root of 36 is just 6. So that's what we're going to be using this property for. Now, we're going to be using it for simplifying radicals, and now the difference between simplifying radicals and evaluating radicals is that you don't want to use decimals when you are simplifying the radicals. You want to break the radical down like illustrated here, so that the number underneath, or the radicand, is as small as possible. Okay, and so in this example, we're going to be simplifying the square root of 48. Now, in order to simplify the square root of 48, we're going to figure out the biggest perfect square that goes into it. Now, if you don't know what a perfect square is just a number that is the square of something. For example, 4 is 2 squared. And sometimes it helps when you're first doing this to make a list of perfect squares. So I'm just going to do that quickly. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And then we have 7 squared, which is 49. And there's no point in going any higher because our number is only 48, and we've already passed that number. We're just going to start checking them to see which one is the biggest that goes into 48. If you struggle with math, just make a list like this and start at the next biggest one, so the one that's just barely smaller than the number we have underneath the radical. So in this case, I would try 48 divided by 36. Is that a whole number? Well, if you type it into the calculator, it is not a whole number. So I would just go back and do the same thing for each of my numbers. 48 divided by 25, that's not a whole number either. But 48 divided by 16 is a whole number. 48 divided by 16 is 3. So since it's a whole number, what we're going to do is we are going to break apart the number inside the radical. We're going to rewrite it as 16, which was my perfect square, times 3. Now, according to the property we just looked at, we can separate these two into two separate radicals because they are connected by multiplication. So I'm going to rewrite it as the square root of 16 times the square root of 3. And then if we can evaluate either of these radicals further, we would. Now, if you're doing this process right, one of them should be a perfect square, and the square root of 16 is a perfect square. The square root of 16 is 4. We can't square root 3, so it's just going to come down and stay square root of 3. So the final simplified version of this radical would be 4 square roots of 3. And if you were to type it into the calculator, you would get the same decimal result for both answers. I didn't mean answers, I meant for the original problem and the answer that we got, you would get the same decimal approximation. Square root of 48 is approximately 6.928, blah, blah, blah. And if you were to type 4 times the square root of 3, you would also get approximately 6.928. We're not actually changing the value of what this expression is, we're just changing what it looks like. Okay, in this example, we're going to be simplifying a radical. We have 5 times the square root of 24. Now, what's important to look at whenever we see this one is that this 5 here on the outside is not a superscript. It is not written as this. If it was up here, that would be the index of 5, which means it's no longer the square root. Right now, I'm just looking at square roots. Okay, so what does the 5 mean? Well, because it's not a superscript like that, it's not the index, it's just a 5 connected by multiplication. So we're just going to handle the square root of 24 as we did before. We're going to simplify as much as possible, finding the biggest perfect square that goes into 24. And if you need to, just make a list of perfect squares. I now have on the side here, you'll notice I have been skipping 1 squared because that doesn't really help us in the process of simplifying radicals, even though 1 is a perfect square. But it might help when you're learning this to keep one of these lists handy so you don't have to rewrite it every time. But if we look for the biggest one that goes into 24, well, 25 is too big. 24 divided by 16 is not a whole number. 24 divided by 9 is not a whole number either. It's 2 point something, and then it looks like 4 works because 24 is 4 times 6. So I'm going to go ahead and rewrite this. We have our 5 that's just going to chill there, and we got our 4, which is our perfect square. And since 24 is 4 times 6, I'll rewrite it as 4 times 6. Now I'll go ahead and separate the radicals. 5 times the square root of 4 times its own radical, the square root of 6 now. Now that we have this, we'll go ahead and simplify any radicals that we can. The square root of 4 is 2. Now this 5 and the 2 are connected by multiplication because the 5 and the radical 4 were also connected by multiplication. You'll notice there's no sign there because it's implied multiplication. I'll add it now. So my 5 is just going to come down, just chilling for now. And the square root of 6, well, 6 is not a perfect square, and we can't break it down any further, so we're just going to drop the radical 6 down. And in this case, we can do a little bit extra. We can actually multiply these numbers out in front of the radical, the coefficients for the radical, back together. 5 times 2 is 10. So overall, the simplified version is 10 radical 6. And as you gain more experience with this, you won't have to write out some of these intermediate steps. You can probably actually skip those steps as you learn it. I do recommend writing this down. This way your teacher can kind of see what your thinking was as you broke it apart.